Hello, greetings from the World Maritime University. Welcome to this new series of WMU Alumni Webinars focused on contemporary maritime education and training topics. My name is Professor Momoko Kitada, Head of Maritime Education and Training at World Maritime University. As the industry undergoes rapid and far-reaching technological transformation, continuously strengthening competence-based training while simultaneously harnessing the potential of digitalization is essential. These issues are at the forefront of the IMO's Human Element Training and Watchkeeping HTW deliberations. This three-parts webinar series focuses on the critical areas of exploring the opportunities and challenges of artificial intelligence in MET, human factors and non-technical skills in VTS training, and enhancing onboard training. These themes address how knowledge is created, transferred, and applied in the maritime sector, and directly influence the competence, safety, and sustainability of the global workforce. Through expert insights and active alumni engagement, this series offers a unique opportunity to examine how innovative training practices, emerging technologies, and a renewed commitment to human well-being are collectively defining the next generation of maritime leadership. Today, we deliver the first session of the MET webinar series. Next slide, please. Titled Artificial Intelligence in Maritime Education and Training. A speaker is Dr. Hassan Mohab Tasher from Kongsberg Maritime. I would now hand over to today's moderator and discussant, Professor Johan Bomsten, our MET team at World Maritime University.
Thank you so much, Professor Kitada, for that introduction. I have the pleasure of being the moderator and the discussant today. So my name is Johan Bomsten. I'm an assistant professor in Maritime Education and Training here at the university. I'm specialized in e-learning and knowledge management, and I've also been working a lot with the development of the university's e-learning program going back. Today, we have the pleasure of having Dr. Hassan Mohab Tasher as the speaker. His PhD was on virtual reality in maritime simulator training and assessment, and he's now working as an engineer at the engine and cargo simulation section at Kongsberg. Before we begin, I will give you the outline of today's session. So I will begin by doing a short introduction. Then I will hand over to Dr. Hassan for his presentation. During Hassan's presentation, you are more than welcome to post your questions in the Q&A section of the webinar below. So then following Hassan's presentation, we will pick up on as many of the questions as we have time for. And Hassan and I will discuss and try to answer your inquiries. For the questions that we might not have time to answer, we will follow up with written answers following the webinar. Please also note that we record the entire webinar today, and it will be made available after the webinar session. So having that said, let me do a short introduction. So I think unless you have been living under a rock, you have been using and been subject to AI for the last years. And actually for a long time, maybe without even knowing it. So put simply, AI is the capability of computer systems to imitate intelligent behavior, like learning, reasoning, problem solving, and decision making. For good, and maybe also for sometimes for bad, AI is becoming part and parcel of our everyday life. lives. It might be debated, but one common assertion is that actually AI is one of the great issues facing humanity alongside with climate change and increasing levels of inequality. Probably you have already kind of actively or directly used AI through services such as ChatGPT. But in any case, AI is today the backbone and integrated in your search engines, social media, productivity tools, and increasingly also in education. So, for example, when you do a search in Google, AI helps to generate your search results. And these capabilities are, of course, becoming ever more powerful and explicit. So, for example, returning to the search example, your search results are now commonly summarized into text, and you don't even have to click the individual links anymore. So AI in the form of what we refer to as large language model exploded with the launch of ChatGPT, now some 3 years ago. However, AI has been around for a long time. Hassan will give some more perspectives on this in his presentation, but I can just tell you that I have a background myself in information system sciences and as a software engineer. And already some 25 years ago, when I did a master program in knowledge management at one of the major universities in Sweden, AI was a major component. And I remember how very kind of revolutionary and different it was already then. So instead of telling the computer exactly what it should do, it could, to different degrees, make decisions itself. Back then, and many AI applications that were on the table then were in the form of decision support systems, was something that was quite common in knowledge management. For example, I was part of programming an AI system for some banking services. Moving into the maritime domain, I remember quite early on, there was development and research about container optimization using AI, which in the maritime domain. I remember when I began teaching knowledge management as part of the Maritime Education and Training specialization here at the university, from the beginning, AI were included in bits and pieces here and there. But now it's a substantial part of the course. And I will not take away too much from Hassan's presentation, but we work here at the university with AI in form of customized learning, assessment, learning analytics, and of course, programming in itself. So I look forward to following up on many of these issues together with you following Hassan's presentation. And with that said, I leave it over to you, Hassan, for your presentation.
Thank you, Johan. My name is Hassan, and I'm very glad to be here. I will share my presentation first. So, Johan, you can see my screen, I hope. Yeah, so my name is Hassan. I have a little bit of background from working at sea, and then I transitioned into academia. And recently I have started working in Kongsberg Maritime in the R&D of simulation department. So this is one of the presentations which is very relevant in today's context. And I try to have an observer's perspective in what's happening in the AI space and try to connect it with MET, Maritime Education and Training. And together we will try to explore a few questions so that then at the end we have something to discuss about. So what is AI, first of all, and then how AI is used in higher education today, to get some examples, and then how will AI affect MET in general, and what are the concerns that we talk about AI that might affect in future, and also how should we prepare for potential AI integration. So first of all, what is AI? If we look into a sort of continuum of AI from its origin to its current form, calculator is a basic form of automation. We can call it AI because it's calculating. It's an artificial machine and mimicking human intelligence on a larger scale. And then if we move a bit advanced, these are rule-based systems. Most of the AI or automated systems are rule-based as of today. So we give particular instructions to a machine, and machine behaves in a certain way. So that's what we call rule-based systems. And then moving forward, we have narrow AI, which is very good at recognizing patterns in a specific context. Either it could be in data or in image. So the main characteristics of this kind of AI is that it can recognize patterns. And then a bit advanced is contextual AI. A lot of examples we see as of today. So it can recognize pattern, plus it can take actions. So autonomous cars or autopilot assisted cars, that they can recognize pattern on the road and take actions based on that. That's why we call it contextual AI. It is very good in a particular context. And then moving on in forward, we will see some sort of theoretical form of higher intelligence AI, which we call it artificial general intelligence. We haven't reached there yet, but it is speculated that it will have human level intelligence. And a bit advanced would be artificial superintelligence. So the difference between artificial general intelligence and superintelligence will be that the lack of emotional intelligence. So superintelligence will have human intelligence plus emotional intelligence, which general intelligence will not have. So these are top two AI part is more on a theoretical level. We are still on the contextual AI era. And then if we summarize what different kinds of AI can do in general. So we know now today that AI can understand language, more recently natural language. So the language we speak, AI can understand and take actions based on that. It can recognize patterns, either in images, speeches, or data. It can make decisions based on data or recognize pattern, and it can learn from data. And also there is a reasoning part, which is increasingly getting popular or important in the AI space. That's AI can reason and take actions. So considering these capabilities of AI, how we are using it today in higher education space. We looked into some of the literatures until very recently and see that AI is mostly used in research as of today. It's not a widespread technical tool that are being used in everyday education. Rather, it is heavily used in research to find out how we can better use AI in the future. And then there are some speculations, a lot of articles, scientific papers term AI in different way and speculate in a different way. But in general, if we look into the journey of an instructor or a teacher, we can categorize in three parts. So during planning, he can use AI or might use AI in some tasks. During implementation, in the classroom or while he's teaching, he can use AI in certain ways. And during assessment, at the end or throughout his teaching journey. So categorizing these three areas, we see in literature that during planning phase, instructors or teachers use AI mostly in decision-making on learning content. What to teach and how to teach, brainstorming on a particular topic. So this kind of stuff. And then also a little bit on student administration to select students of a particular profile, because student selection is very important when you are going to teach a particular topic. So AI has potential in that area. And in implementation phase, it generally reduces teachers' workloads, whether it's administrative or reporting or planning. And it can help in adaptive content delivery of teachers. So I will come back to that more. AI can be used in real-time tracking, assessment, and intervention in the classroom and post-classroom also. It is used to increase engagement and motivation, to gamify learning contents. I'll come back to that also. And more importantly, it increases students' accessibility to the contents in different way. The students don't rely only on one media, for example, classroom or teacher's lecture now. So they will have more opportunities to engage with the learning contents from a different angle, either through text, video, chatbots, and so on. And also a bit on teacher evaluation, AI can be used. And in assessment, I will elaborate mostly in assessment part because that's more relevant to MET based on the current research as we have today. So we will be able to predict student performance more through enhanced prediction, and assess, we will have more tools for automated assessments, not just manual ones. And we will be able to use AI to improve student retention and prevent dropout of students, and also to track students' health and well-being. So these are the examples that AI is being currently used in the higher education space. But on a theoretical level, if we see how students learn, there are three main theories which we follow in the universities or schools to formulate our instructions around it. So first is the behaviorism. This is a process through which students learn, and if they depict a particular type of behavior and they're rewarded, they will be more inclined to do that again and again, and in that process they learn. So in behaviorism, we shape students' behavior or learners' behavior through reinforcement and conditioning. So either reward or punish. If you reward for a certain type of behavior, students will come back for more for that behavior. So using AI, we can gamify that process, either through scoring or giving stars. In kindergarten schools, we have seen. So since learning will become more digitalized, we will need AI assistance to make it gamified and provide those reinforcement through AI. And then cognitivism is another concept where we learn complex things. At first, we make smaller chunks of those complex things, store in our memory, and then when needed, we retrieve it. So mental processing, memory, schema, these things are involved. How AI can help is naturally AI can break down complex theories in small chunks, and students can do that without teachers present always. So that's a major area where AI can be helpful. And then constructivism is another theory where less knowledgeable learners come in the vicinity of more knowledgeable others. So in MET space, we call it trainees come in proximity of more experienced sailor, say, for example. So that area or that zone, we call it zone of proximal development, where the interaction between the less knowledgeable and more knowledgeable people will eventually form new knowledge or knowledge sharing in a controlled space. So in that sense, instructors can help students achieve higher learning outcomes. So teachers will use AI as a scaffolding so that students will be able to achieve the learning outcomes faster. So that's the main theory of it behind AI use. So now how AI can be used in MET. We will mostly focus on what happens in MET institutions and from an instructor's perspective. Of course, there are a lot of other areas in MET or in lifelong learning, course validation. We will not focus on that. So how AI can be used in MET institutions during the pre-C training phase. So we can speculate based on our learning on how AI is used in higher education space. We can speculate based on that what will happen in MET also. So broadly, the method of teaching will change from traditional teaching where teachers deliver content and students are the receivers. In AI space, contents will be delivered on demand, so based on students' question. So that's what we call it adaptive learning. And then there will be more examples we will see in future of learning analytics. We'll have to analyze different types of data sets that we gather from students, whether it's performance data or classroom attendance or their health data, how their learning is progressing, and so on. And then we will get an overall picture of students' learning journey using data analytics, and AI is a big part of that. And assessment methods will change. We'll move towards more formative assessment rather than final exams or summative type of assessments. Formative meaning we will be able to assess, track students throughout their learning period, not just an exam at the end. And there are some other scattered applications of AI we will see, especially in simulator training. That's through performance prediction, continuous assessment, or at the class, we at-risk student identification. So these are the examples we didn't come up suddenly. These are examples from other domain. So in healthcare domain, in neurosurgery, we have been doing a bit of collaboration with the healthcare domain and how they use AI in their simulator training. And we see that as of now, they use two types of direct use of AI. One is classification of expertise and another is continuous assessment. So what happens in classification is that multiple surgeons with different level of expertise perform a particular surgery, and they gather all the data and they classify who did well and who did mediocre, who did not so well. So this is the data they use to train an algorithm, and the same algorithm can be used to classify new type of data. So what I mean is that in maritime context, let's say if we train an artificial neural network in a simulated environment from participants' data, starting from very novice to expert, and then we have a trained algorithm. The more data we have, the better. So that algorithm can be used to classify any new students, like how he performed as an expert, semi-expert, or novice. So it's not that these tools are new. These tools exist as of today. It's just we are not accustomed to using it, and there is no structured way to use it as of yet. So we gather data, train an algorithm, and the trained algorithm can be used to classify new performances. So that's the basic idea of it. And on the other hand, continuous assessment is just using a separate type of algorithm, so which will give us a real-time performance assessment. For example, on the left side, you see a surgeon is performing surgery on a brain, simulated brain, of course, and at a particular instant, how he is performing. Is he less skilled or highly skilled? It's a form of continuous assessment. So same theory we can apply in maritime simulator training. So that's another speculation or a possibility, I would say. And in addition, we have seen many examples of using psychological data, physiological data in simulator training to measure workload stress in seafarers or trainees, along with eye tracking data also. These are kind of triangulation data which we can use to improve our prediction accuracy. So in future, we will see these examples of triangulation and more advanced kind of assessment techniques in simulation and in classroom in maritime context. So these concepts we have been talking a lot about recent years, and we have been discussing in different scientific conferences also. Another example is identifying at-risk students. So this is a study we did last year, or a year ago. So the main idea is as maritime students, let's say he has 4 semesters, he takes a lot of classes or subjects in each semester, and then teachers will be able to understand how a student will perform at the end based on his first semester results only. So how we do that? We take historical data, how the previous batches did on different exams. We take examples from 3 previous classes, and then we train an algorithm. And then that algorithm is used to identify new or that can understand patterns in any new data set. So any future students' data, if it is fed to the algorithm, it will show that, okay, this student will perform better at the final exam. So here you can see on top, these are 4 means last semester exam, 4. So 1, basic electrotechnology, first semester exam results bears significant weight to predict how he will do at the final exam. So similarly, there are some other subjects also which teachers can identify and give adaptive instructions to specific students. So that's one theory, and also we can categorize a group of students on different subjects, how well they're doing. Is it above average or below average, and so on. And also, broadly, the role of instructors will change in MIT institutions. How? The instructors are providing instructions as of today, but they will become more of mediators, supervisors, resource curators, and so on. So they will act as an agent, which I'll come back at the end, how it will happen. So in general, future role of instructors will become more like being model for AI training and feeding AI systems with different students and teacher related behavioral or performance metrics. And they will be checking the accuracy of assessments, of course, and determining the assessment criteria, what type of performance is good. Only a human can say that. Machine is blind in this area. So the instructor's role will be very important. And providing pedagogical guidance. So teachers will decide when we need to stop AI intervention. So AI cannot take over 100%. So there should be some human intervention or supervision in the process. So instructors will do that. And also they will provide feedback on technical issues. There are some concerns, future concerns, especially in maritime training space. So if we continue using AI heavily, there is a risk that the AI will lack perspective and contextual data. So in MIT institutions, mostly the instructors that we have experience from sea, which they transfer in a classroom or simulated settings to the students. So if that task is handed over to AI, it will lack the contextual realities of working at sea in an engine room or in a bridge. So that's a risk. And also there is a risk of producing pedagogical atrophy. So that's what I said. So we will move away from pedagogy and lean towards AI. That's the risk. From the student side, as they rely heavily on AI, there is a risk that they might not develop certain skills that are needed. So that's a risk. And also there is a concern related to data. So what type of data we use to train our AI algorithms has a major impact. So let's say if we use only eye tracking data to train our algorithms, then that AI will perform in a certain way, as opposed to if we use interview or observation data or numeric data. So there will be bias in data on a trained algorithm. And one of the most relevant problem is that there will be access inequality by default. So once we move towards more or heavy AI use, it will get certainly more expensive, and naturally it will create access inequality throughout the world, because it's these AI models and features are not so affordable across the world. So that creates inequality by default. Yeah. So what's ahead? How can we prepare for the future? So this is a screenshot from a YouTube video I was looking into the other day. So in 2001, when we saw cameras on phone for the first time, not everyone was convinced that this will stay as a part of our phone, or we will use it so heavily in future. So AI is like that. Even today we see AI is less used or more used. We don't know for sure how it will pan out 20 years or 30 years from now, unless we strategize. Similarly, we had post boxes from the very early ages, but we couldn't get rid of post boxes yet. So when a technology comes, it is here to stay. It depends on how we strategize or make the technology accessible to all in a certain manner. So all in all, AI will not replace MET structure, but we need better strategies to coexist. So how the strategies would be in the future, or should be, to determine that, we have to look into specific components of technology. For example, if we look into pedagogy solely, then it is human mediated. There is intentionality, provenance, there is literacy, meaning making, all sort of stuff. But when we look into AI, it's totally algorithmic or numeric mediation. There's data, simulation, and all of this. These are two different contexts we are talking about. And in the middle, we call this agency, whether it could be teacher's agency, student's agency. And depending on context, these pedagogy and AI will diverge from each other or converge. So in a particular task, we might need a lot of pedagogy, a little bit of AI, and in some other tasks, we may use a lot of AI, a little bit of pedagogy. So never only AI or never only pedagogy in future. So that's how the future looks like, and there will be a lot of other mediation. For example, how the school, college mediate in this interaction, how the edtech industry mediate, what they have to offer, that affects a lot. And then government legislation, policies, it will affect also how this mediation occurs between pedagogy and AI. So that's how the future looks like, and our strategy should be to understand each components of these interactive materials, and then naturally we will have more clarity of how to use AI. So future will be mostly AI mediated, at least in the learning context. So therefore, we have to cultivate self-regulated learning skills into students. So students should be able to set their own goal, should be able to self-monitor their progress and self-assessment to a degree. Otherwise, we cannot expect that AI will be effectively integrated. And we should be also, of course, responsible in using AI tools and should be aware of their social, emotional, and technical aspects. And future assessment tools should be focused on assessing higher order thinking skills like critical thinking, creativity, and these sort of things. So as of now, the assessment methods we have today, for example, essay writing and comprehension. So these type of assessment tools or procedures will be obsolete. So we have to focus more on how to assess students' higher order thinking skills and their creativity. And then institutions, the responsibility of the institutions will be to provide comprehensive training and data literacy skills to both teachers and students. And then, as I mentioned in the previous slide, we have to develop a critical understanding of how AI will affect our everyday pedagogical practices and the differences between AI-mediated learning and human-mediated learning. So these are the components that we should be aware of, get ourselves accustomed to, and then, if required, get training so that we can use these tools and methods effectively. And also, we need concrete societal policies. So here it comes the society, mediation, and the components of it. So we cannot use AI heavily or 100%, neither we can avoid it 100%. So there should be some policies around it, how, when, how much we should use AI in learning context specifically. So these are some of the recommendations based on what we see in literature and in practice and in industry as of today. So this is my presentation in short. Thank you for listening and your patience. So we look forward to questions, I guess, Johan.
First of all, Hassan, thank you so much for a very comprehensive and thoughtful presentation. There is so much to unpack here. I can already see that there is questions coming in, and if you have something, the audience and the participants, if there is something that you're thinking about, you can still kind of post your questions in the Q&A session of the webinar, and we will do our best to pick up on your questions. But let's dig into it, Hassan. We take the first one here from Awad, which is about intended learning outcomes, I think. And he's asking how the quality of learning outcomes can be controlled when, in my understanding, when using AI. So how, when we are working with intended learning outcomes and AI, what are some of the considerations? Do you have any thoughts, Hassan?
I think what he meant is how can the quality of learning outcomes be controlled by not using AI instead of thinking? Okay.
Yes, please.
Here, I think the most important part is at the very last slide where I mentioned the characteristics of pedagogy and AI. So human-mediated and machine-mediated learning. So I still think that machine-mediated learning will not be 100%. It will always be an assistive technology. So the quality of instructions, the structure, or planning and implementation, mostly I would say 99% depends on the teacher. So if we want to ensure quality of learning outcomes, we have to have better instructors who understands, first of all, the topic, and then also understand what's other AI or assistive tools have to offer, only then he will be able to filter out unnecessary interventions from tools, and then focus fully on preparing his instructions and focusing on making his learning contents based on the learning outcomes. So yeah, maybe I'm talking a bit haphazardly, but the main idea is that we will have to focus on human-mediated learning first. Only then we'll be able to have better learning outcomes.
Yeah. And in my experience, what I have been part of here at the World Maritime University, that this is a substantial, not easy consideration, but on the part of faculty and instructors, and also with the dialogue with the students about how are we using AI in education in a good way. So it's not black and white, right?
Yeah, exactly.
Yeah, and this is actually also relating I think Avad's question here is also relating a question that was in part answered also by our registry department, that has to do with how and if AI is allowed also kind of in relation to use AI in assessments and how we monitor the students and these kind of things. And I think I would also like to say here that our registry department here, they stated, for example, that WMU has a AI policy. But I think in addition to that one, where I have to give WMU credits, was that there was also kind of a very active dialogue and reflection with us in the faculty, and also sessions with the students with feedback about the AI usage. So it's not kind of only a static policy, but a active reflection process about how it can be incorporated and used in the learning. So in fact, at least at WMU, AI it's not forbidden, but the point is to be transparent and explicit about its use to achieve different types of learning objectives. So for some learning, AI can be very suitable. For some other things, not at all. And this has to be very kind of clearly defined and reflected on. Do you have anything more that you would like to add in relation to this point?
No, I think you covered well. Again, it's institutional level mediation. There should be some guardrails, of course, that you cannot use all types of AI models that are available in the market. So that's the institutions to decide.
Yeah.
Yeah.
Yeah. This is also relating some other questions about if there are kind of tools available, agents available for kind of assessment development and for assessment when it comes to AI in education. Do you have any experience with such tools, Hassan?
Well, it's difficult to pinpoint a particular type of tool. It depends mostly on what you want to assess. If it's an essay or it's a report, then any of the available tools work more or less. Any LLM models, I'll not name names, but you know. But if we want to be a bit more advanced, then we have to have certain skills to understand how the tools work. So there are different platforms like Data Robot, I showed in a slide, that we use to upload all our students' data, their exam results, and then based on our input, it gives us a most suitable model to use. So these are called AutoML, automated machine learning. So if you search in Google, you will find a lot of them in online, free or paid. So you just have to find the tool that is most suited for your assessment case.
Yeah. Yeah. And I can also add that there is today a lot of tools that are also kind of built into the learning management platforms that we use that can help with AI detection. For example, you can use them where students upload their assessments and it can check AI usage in the same way as you check plagiarism, for example. But I think what is important there to remember is that these tools are far from perfect and you cannot rely on them 100%. So I think a lot still comes down to the instructor to actively work with assessing scripts from the students, submissions from the students, and also kind of working with the students to understand their achievement of the kind of intended learning outcomes. I think, Hassan, you had a slide about the possibilities and differences between formative and summative assessments, which I think is also interesting consideration when it comes to AI. Is that something you can elaborate on a little bit more?
Yeah, the main idea of that slide was since we will be using more AI, and then we will be able to track students more throughout their progress.
Yeah.
So as a result, we will be moving away from a summative form of assessment towards more formative. So summative form of assessment is the final exam that students participate on, and they get a final grade. It doesn't matter how they perform in the class or how their learning journey has been. So the formative part is taking into more data point throughout their learning journey. But I didn't stress enough the need for instructors to be aware of different AI characteristics, so that when they read a text from student, they can identify if it's AI generated or not. That could be a skill needed in the future, I think, because since most of the add-ons in our already built in in our tools that we use to detect plagiarism, sometimes it also hallucinates. So then the teacher has to intervene, like you mentioned. So that's a skill I think moving forward that teachers might need also. So unless they use these tools themselves every day, it will be hard to build that competence.
Yeah, true. Oh, now we have a lot of questions coming in suddenly. So we only have some few kind of precious minutes left, but maybe we move on to there are some interesting questions also about kind of gamified learning and possibilities of using AI, which I think gamified learning has obviously been around for quite a long time, but I'm thinking that AI here, and we see some novel development where this can kind of introduce some quite advanced and new elements. Or what do you think, Hassan? Do you have any examples of this, of gamified learning?
Yeah, I think the most, at least in Scandinavia, most familiar example is Kahoot. It's a form of gamified learning where students are more interactive, and then they get scores and they have time pressure to answer questions. So that's all part of small components of gamified learning. And then instead of using a platform like Kahoot, teachers can make their own sort of programs or activities using AI. So previously it would take a month or a week to develop something like a gamified context, but now teachers can explore what is possible and what not. So that's the reasoning of mentioning it.
We actually worked here at the university and in development of some of our distance learning programs with gamified learning and also kind of before the AI and on an advanced level beyond the kind of Kahoot. So where basically, so gamified learning where, so for example, we worked with this a lot in our distance learning education. So instead of just having kind of a linear learning path, you can have customized and different learning paths. So depending on the students' interests and maybe how they're scoring on different assessment, they can progress differently through a e-lesson. And you can have really kind of interactive learning here, where the students are working with very advanced in graphical environments with avatars and these kind of ways. And I think what AI can introduce here is even more of those customized learning paths, and can be able to kind of interrogate. For example, you can include assessments that can interrogate the students beyond just kind of static questions, but based on the students' answers, it can continue to probe the students in kind of different levels to kind of understand the achievements. So I think in terms of gamified learning, both to develop gamified learning and to deliver gamified learning, there will be a lot of AI coming, and there already is in the future. And I think one related topic and question that I wanted to pull up, Hassan, also given your work at Kongsberg and maybe given your PhD work about virtual reality, how about AI usage in simulator training? What have you seen there? What do you know about?
I think it's first of all, it's not a worldwide phenomena that all the instructors already use AI to develop their exercises during simulator training. So, but I know that many instructors use AI to develop exercise scenarios to make it more complex. And then based on that scenario or that summary of scenario, they develop, they program their exercises in a sort of to focus on a specific learning outcome. And then specifically in simulation, we have seen also examples that the instructors extract data from the simulators and then train an AI model and try to give a real-time assessment in a dashboard or in a, let's say, learning analytics dashboard sort of way. Yeah. So I'm sure there are a lot more examples how teachers use AI in the simulation space. But in our side, in development, R&D, we use a bit differently. So that's,
Yeah. I have seen some quite kind of novel examples recently in kind of simulators where you have an AI working as a kind of active agent within the simulation training. For example, in teamwork exercises on a bridge or maybe between ships and things like this. Is that something that you have experienced, Hassan?
Yeah, there are a lot of experimentations ongoing, especially debriefing sessions during simulation exercises. So briefing sessions, the instructors has to plan and deliver the briefing, and during debriefing also. So if AI can take a part of it, then it's sharing some workload with the instructor. So AI is sharing the workload in a way. And the tracking is much more effective for the students. So whatever has been said and what the students acted based on the instructions, that's easy to track if we use AI and digital tools. So yeah, I agree. There are some examples and also some upcoming projects which I know AI is being used heavily.
Yeah. Let's see what we have more. Again, we will come back. There is a lot of questions coming in here, and we will come back with written answers to the ones that we don't manage to answer now. There is some question about the kind of the trajectory of AI development. So you talked about this kind of the super intelligence and these kind of things. How fast do you think that will go, Hassan? What do we have? What do we have in front of us?
Well, if you asked me a couple of months ago, I would say very soon. But now, not so soon, because the main baseline or the main model based on which all the LLMs, AI is not only the LLMs or chatbots. It's much more. But particularly talking about LLMs, the main baseline upon which it's built on, it was expected to be much more efficient, but now we are seeing examples that it has hit a ceiling, sort of. So the scaling issue is there. So you cannot scale up as long as you want. It is exponential scaling until a certain period. So now if you use much more GPU or much advanced data centers, it's not likely that it will become AGI or ASI. So what we will see is much more complex implementation of contextual AI. What we have today, it will be applied in a setting which is much more complex and still as an assistance to human work. So that's how I think today.
I think I agree, Hassan, and we don't really know today. And I think also, as you were on to, it's important to remember that there is other AIs than the large language models as well, where some of the prominent researchers actually would say that the large language models have peaked in terms of their development. That is not to say that there will not be massive development in terms of applications of the large language models. There, I think we're only in the beginning, but I think we might also have other types of AI that is being developed. Well, I will ask one final question on myself, Hassan. Today we have there are some very big companies that are developing AIs. We have the OpenAI, the Google, and so forth. At the same time, in this webinar, we have alumni students and students from all over the world, former students. What do you think about the need to diversify the development of AI models? Is there a danger that we only have a couple of big ones? How is that looking like to you?
Well, there are a lot of different aspects to it, different dimensions. So you have to, at certain point, you have to think about a balance. What do you want as an applicator? So if I want to use AI, what do I want to achieve using that? So, of course, I mentioned about access inequality, which will become more acute over time. And to counteract that, there will be need for more open access models, which we see examples already. But the problem is that the open access models don't have, or naturally would not have that much capacity, if I say simply, especially in a commercialized world. So if we want to do heavy work, then eventually we may need to look for what's available in the market on a broader scale. But if we want to use AI in a more contextualized scale for our own use or for a very specific context, I think open access or contained model will be much more used. And I am very bullish that in few years, all of us will be using our own customized models in our own PC to do particular tasks. So that's how I see the development in future.
I think that's some good considerations, and I would really enjoy to continue the interrogation and discussion with you, Hassan. But unfortunately, time is running out. So I would like to thank you so much for your presentation and discussion with you. It was very interesting. And thank you so much also for all the questions that have been posed by the participants. And again, we will follow up. I realized that we did not manage to answer all of them, but we will follow up there. So I thank you so much. I will invite Professor Kitada for the closing remarks. Please let
Thank you very much, Johan.
Share my screen. Professor Kitada, please.
Thank you very much. Thank you, Dr. Hassan and Professor Johan, for this very interesting first session of the MET webinar series. We have 2 more webinars scheduled in April and May, as you've seen on the screen. I'm just also adding a link on the chat. I hope that everybody can see it. So this is the link that you can also further look for the registrations, because each webinar has a unique independent registration link. So if you are interested, please register through the link on the chat. And if you have done already, we are very much looking forward to meeting you again. So thank you very much for your participation, and see you at the next webinar. Goodbye.
Thank you.
Thank you so
Thank you.
much.
Bye.